Hi, today we're looking at Functional Skills Maths Level 1. We've got the Highfield exam board and we've got paper FSQN 109P. We're going to start with the non-calculator section. Question 1. Write these fractions in order from smallest to largest. Well, at the moment, they're not all the same denominator. But we can see that 4, we've got 2 4s in the denominators and 4 goes into 8. So what we can do is we can convert these two fractions into equivalent fractions, so they're all going to be over 8. And then we can just compare the numerators. Okay, so if I want to rewrite this one as being over 8, then I know I can have 8 as the denominator, because as I say, I can see that 4 goes into 8. In fact, you've got 4, 8, so it goes into it twice. So we're doubling the denominator. So whatever we do down there, we need to do the same to the numerator. So if we double the numerator, so 3 times 2, it's going to give us 6/8. Okay, so these fractions are equivalent, but now you can see we can easily compare, or these 3 fractions we can compare. So what we want to do is the same sort of thing with this one here. Well, again, if we want to make the 4 and 8 exactly the same as before, we're doubling the 4. So we need to double or multiply by 2 the 1. So now we've got 2/8. So the fractions we're comparing, so we can forget about that one and that one now. We've now got 6/8, 3/8, 1/8 and 2/8. And we want these in order from smallest to largest. Well, the 1/8 is going to be the smallest. Well, 2 comes next, although the original fraction was actually 1/4, so I'm going to write it in the form they originally gave us. Then we've got 3/8, and finally the biggest one is 6/8, but they actually gave it to us as 3/4. Question 2. Work out the value of 25 squared. Right, so with this one, we could write it as a column. So we could do, well, 25 squared means 25 times 25 times itself. So we could do it using a column method. I'll show you an alternative method as well. So we can say 5 times 5 is 25. 5 carry the 2. 2 times 5 is 10. Add the 2 is 12. 2 and 1. Now we're moving on to the 10, so we can put a 0 down here. 2 times 5 is 10. 2 times 2 is 4, plus the 1 is 5. Then we can add these together. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. So that's our answer. Now, not everyone likes doing the column method, so instead what we can do is we can do the grid method. And with this one, still multiplication, the 25, we're going to split it into tens, so 20, and units, 5. And the other number, we're going to do the same again, so the tens are 20, and the units are 5. And now we're going to multiply everything down here with everything up here. So 20 times 20. Well, we can just do the 2 times 2, which is 4, and then put this 0 on, and that 0 on. Now over here, 2 times 5 is 10, and then put the 0 on the end. So this is going to be the same. 2 times 5 again is 10, 0 on the end here, and 5 times 5 is 25. Then all we need to do is add up these numbers. So we've got 400, 100, 100, and 25. So 0, 0, 0, and 5 is 5. 0, 0, 0, and 2 is 2. 4 plus 1 is 5. Plus 1 is 6. So you get the same answer. So these are alternatives. You don't have to do both ways. Either one's fine. Okay. Question 3. Calculate the value of 12 plus 12 times 12 minus 12. So we've got to think about our BIDMAS rules, order of operations. What do we do first? The plus, the times, or the subtract? Well, with BIDMAS, we've got B for brackets. We've got no brackets. I for indices, so squared or cube numbers. We haven't got those. D for division. We haven't got any. M for multiplication. Right, so we need to do the multiplication first. Well, hopefully you know some times tables, so 12 times 12. But if you don't, again, well, I'm going to do it using the column method this time. So 2 times 2 is 4. 1 times 2 is 2. Onto the 10, so we put a 0 here. 1 times 2 is 2. 1 times 1 is 1. Add these up. 4 plus 0 is 4. 2 plus 2 is 4. 144. Okay, but if you can practice your times tables and know this, it will just save you a lot of time. So we've got 12 plus, so this has now been replaced with 144 and then minus 12. So now, because we've just got plus and minus left, we just do it from left to right. But actually, if you look at it, we're going to be doing 12 plus 144. So we're adding 12 on, and then we're taking 12 off. So actually, they're going to cancel each other, and we're still going to have 144. If you don't feel comfortable doing that, we'll add it on and then take it off, and you'll see you'll still end up with the same answer. Okay. Question 4. In fact, let's move it up so we can see all of these. Which of these nets can be folded to form a cuboid? Right, well, the first thing I want to think of, well, a cuboid, if you think of, let's draw one, is going to be, it's a box, basically. It's going to be something like that. Okay, and if you think of the box, if I draw the back on, we're going to have a front, a back, a left, a right, a top and a bottom. So we want 6 faces. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Well, it can't be that one. 1, 2, 3, 4, 5, 6. Okay. Okay, but it could be any of these. Well, let's think about how we're going to make something like this. Well, if we look at these 4 in a row, this long bit could be that side there. Then we've got an end. Then we've got another side. And then we've got another end. So they would wrap round to do a side bit. But this could be the top and the bottom. But if you look, this line, when it's folded up, this line's going to go against this line. But they're clearly not the same length. So they're not going to match against each other properly. So it can't be A. What about B? Well, if we wrap these all round, this is like we've got a top, then a side, then the bottom, then the side. So they'd wrap round, and then that will close one end, and that will close another. So that one looks like it can work. What about with C? Well, we've got 1, 2, 3, 4, 5. Well, if we wrap those all round, they're just going to kind of make some sort of pentagon kind of shape. We've got 1 for the bottom, but nothing for the top. And that's not going to fit with 5 around the outside. So it's going to have to be just B. Okay, scenario A, making bread. Question 5. You want to start making bread. You have found a machine that is on special offer. Maxi Bread Maker. List price £189. Special offer 15% discount off list price. How much will the bread maker cost after the discount? Show your working out and write the answer in the box below. Right, so we want to work out 15% and then subtract it from the original price. Okay, well, 15, if you think 15%, well, 15 is 10 plus 5. So what we can do is we can work out 10% of 189. And all we're going to do there is we're going to think, well, we've got a sort of invisible decimal point at the end. Because we want a tenth of it. We're dividing by 10. We're just going to move the decimal point once. So we're going to end up with £18.9. Well, because it's money, it'll be £18.90. Well, if we want 5% of 189, well, 5 is half of 10. So we want half of 10%. So we want £18.90 divided by 2. So we can do this using the bus stop method. Does 2 go into 1? No, because 2 is bigger than 1. What about 2 into 18? We've got 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's 9 times. Put our decimal point. What about 2 into 9? 2, 4, 6, 8. So that's 4 times with 1 left over. And 2's into 10. 2, 4, 6, 8, 10. That's 5 times. So £9.45. So if we want 15%, well, 10 plus 5 is 15%. So we need to add these two together. 0 plus 5 is 5. 9 plus 4 is 13. Bring down the decimal point. 8 plus 9, well, we can do the 9 plus 1 first to make 10. Plus the 8 is 18. And 1 plus 1 is 2. So we've got £28.35. Now that is the discount. Okay. So we need to take that off of the original value. So we've got £189 and we're going to subtract £28.35. Now to give us something to take away from, we can put our zeros on here. Well, we can't take 5 away from 0, so we're going to have to look here to get something. Well, that's still a 0, so what we're going to do with the 9 is reduce that to an 8 and pass that 1 over. And then to get a 1 over here, we're going to reduce the 10 down to a 9 and pass 1 over there. So 10 minus 5 gives us 5. 9 minus 3 gives us 6, decimal point. 8 minus 8 is 0. 8 minus 2 is 6. 1 minus nothing is 1. So we get a total of £160.65. Question 6. You use the following instructions to make bread. 20 minutes to make and prepare the mixture. 50 minutes to bake. 15 minutes to cool. Then it's ready to eat. You want the bread to be ready to eat at 10:30 a.m. You start making the bread at 9:15 a.m. Will the bread be ready to eat at 10:30 a.m.? Okay, so there's different ways you can do this. What I'm going to do, you could add these times together and then add them on to 9:15. I'm going to do one at a time. So I'm going to start with 9:15 and say, well, we want to add on 20 minutes. Well, 5 plus 0 is 5. 1 plus 2 is 3. So that takes it up to 9:35. Then we've got to add on an extra 50. Okay, so we're going to want to add on 50 minutes. Well, 5 plus 0 is 5. Let's do a line here. 3 plus 5 is 8. But actually, we've only got 60 minutes in an hour. So if we've got 8, well, that's going to be too many. So if we think, well, 8 take away 6 is 2. And we can carry 1 over. Now 9 plus 1 is 10. Okay, so if you see, we've gone from 9:35 up to 10:25. So it's taken us 25 minutes to get to 10 o'clock and then an extra 25 minutes to get to 10:25. Okay, hopefully that makes sense. Then we've got 15 minutes to cool. So then we're going to add on 15 minutes. So 5 plus 5 is 10. 2 plus 1 is 3, plus 1 is 4. So that takes us up to 10:40, and that's going to be AM. Well, they want the bread to be ready at 10:30. Well, this is after 10:30 AM. So would it be ready? No. Okay. Scenario B, Highfield delivery service. Question 7. You are a driver for Highfield delivery service. The company has 5 white vans, 3 green vans and 2 black vans. Each morning you take a set of keys at random. On the scale below, put an X to indicate the probability that the keys you take will be for a black van. Okay, well, let's work out the probability first of all. we've got how many vans altogether? 5 plus 3 is 8 plus 2 is 10. So it's a total of 10 vans. We're interested in how many are black, and we've got 2, so 2/10. Okay, well, I'm working out the actual probability because I think this makes it easier to see. Well, and we've then got this line. All probabilities go from 0 for impossible up to 1 certain. And they split it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections, which is great. We want 2/10, so we're just going to go 1, 2, and put them up there. So we know it's not certain. We know it's not impossible. For it to be even, we'd need 5/10 or a half. It's less than that, so it's in the right section. And also say we've got 10 parts here. We want 2 of them. Question 8. Your salary is £16,500. Your boss gives you a 5% increase. How much will your new salary be with a 5% increase? Right, so I'm going to do something similar to what we did before. I'm going to say, well, 5% is half of 10%. Well, 10% of 16,500, well, we can just take a 0 off the end. So it's going to be 1650. And then I can put my comma in. So 10% is going to be 1,650. So 5% is going to be half of that. So we want 1,650 divided by 2. So bus stop method again. 2 doesn't go into 1. 2 into 16. 2, 4, 6, 8, 10, 12, 14, 16. That's 8 times. 2 into 5, or 2, 4, 6 would be too much, so it goes twice. 2 2s are 4, with 1 remainder. How many times does 2 go into 10? 2, 4, 6, 8, 10. That's 5 times. So 5% is £825. We want to know how much the new salary will be with a 5% increase. So it's going to be the original 16,500 plus the £825. So we can say 0 plus 5 is 5, 0 plus 2 is 2, 5 plus 8 is 13, 6 plus 1 is 7, 1 plus nothing is 1. So we've got £17,325. Okay. Question 9. The company you work for records the number and type of packages it delivers. Each month, the figures are displayed in a chart. The angles on the chart represent the number of parcels delivered. So we've got large parcels here, small parcels here, and letters here. Let's move this up. Right, let's see how much we can fit on. Okay. So it says small parcels make up 2/5 of the packages. So I'm going to write that. Right. Letters make up 17% of the packages. Large parcels make up the remainder of the packages. And they've asked us to complete the table below, and they want it in degrees. They want the angles of the pie chart. Okay, well, the total degrees in a circle are 360. So we can think, well, if we've got 2/5 of the packages, well, we can say, well, let's work out what 2/5 of this is. Well, first of all, we can say, well, let's work out what 1/5 is. So in other words, we want 360 divided by 5. So 5 can't go into 3 because 5 is bigger than 3. What about 5 into 36? 5, 10, 15, 20, 25, 30, 35. That's 7 times with 1 left over. 5 into 10, 5, 10. So that's twice. Okay, so 1/5. So this is 1/5. We want 2/5. So we want 72 times 2. 2 times 2 is 4. 2 times 7 is 14. So for the small parcels, we've got 144 degrees. Okay. Now it gets a little bit more difficult because we want to work out what 17% is. Okay, so in other words, 17%, we want 17 out of 100 times 360, because it's 17% of the total angles. Right, so how do we want to do this? We could split it up, so we could work out maybe what 10% is, and then 7%. I'm actually going to do, first of all, so there's more than one way to do it. The way I'm going to do it is saying, well, we're dividing by 100, timesing by 360, so I'm going to cancel a 0 and a 0 there to start with, okay? So we've got 17 divided by 10 times 36, okay? But we don't have to do this division first, we can multiply the top first. So we've got 17 times 36. I'll do that down here. No, actually, I'll do it here. We've got enough room. Okay, so we can say 6 times 7. Well, let's do it. 7, 14, 21, 28, 35, 42. 1 times 6 is 6, plus 4 is 10. Then put a 0 down because we're on to the tens. 3 times 7, 7, 14, 21. 1 carry the 2. 3 times 1 is just 3, plus the 2 is 5. So if we have these together, 2 plus 0 is 2, 0 plus 1 is 1, 1 plus 5 is 6. Okay, so we've got 612. But remember, we wanted to divide by 10 as well. So we can move the decimal point into here. So this is going to be 61.2 degrees. Okay, so we can put that in there for letters. So now we just need to work out the large parcels. So what I'm going to do is I'm going to add together this 144 and a 61.2. And to give me something to add the 0.2 to, I'm just going to put 0.0 up there. So 0 plus 2 is 2. 4 plus 1 is 5. 4 plus 6 is 10. 0 carry the 1. 1 plus 1 is 2. So we've got 205.2 degrees. This is total of small parcels and letters. So to find out what's left for large parcels, we need to take this away from 360 degrees. So 360 minus 205.2. So again, we'll put a 0.0, so we've got something to take the 2 away from. And we can't take anything from this 0, so we need to reduce the 6 down to a 5, pass 1 across. Reduce the 10 to a 9, pass 1 across. So now we've got something to take the 2 away from. So 10 minus 2 is 8. 9 minus 5 is 4. 5 minus 0 is still 5. 3 minus 2 is 1. So we've got 154.8 degrees. And we can do just a sort of little sense check. Well, we can see that both of these are quite big and we should have a smaller number for letters, which makes sense. And large parcels should be a bit bigger than small parcels, which it is. Okay. So if you wanted to do it in a different way, what we could do for the letters, instead of doing this, calculation, we could have worked out what 10% was, and then worked out what 5% was, and then 1%, and another 1%, and add those all together, and you'd get the same answer. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. R equals 2t divided by s. Calculate the value of R when t equals 8.5 and s equals 5. Write the answer in the box below. And it's always good to think of this, because we see these as fractions, 2t over s, you might say. But remember, this means divide. If you think of the divide sign, well, this is exactly what it is. The dots are replaced by the things on the top and the bottom. Okay, so this is divide. Right, so we've got 2t. Well, when we've got a number next to a letter, it means times. So we've got 2 times 8.5, and then that's all going to be divided by s, which in this case is 5. Well, we can use our calculator now. So 2 times 8.5 gives us 17. Divide that by 5, 3.4, which we can write down here. Question 2. Work out 22 divided by 1,000. Right, well, we got 3 zeros. We could move the decimal point 3 times to the left, but again, let's just go for the calculator. Okay, and they want the answer to 3 decimal places, 1, 2, 3, so we can just put it straight in here. And there we go. Question 3. You are using a map with the following information displayed. So we've got 1 centimetre equals 5 kilometres. And this is in kilometres, so we've got 5, 10, 15 kilometres. On the map, 2 cities are 25 centimetres apart. What's the actual distance between the 2 cities? Show your working out and write the answer in the box below. Okay, so they're 25 centimetres apart. Well, if 1 centimetre is 5 kilometres, well, 25 centimetres is going to be 25 times 5 kilometres, which gives us 125 kilometres. And we can just put that in here. Okay, question 4. Draw the lines of symmetry on this equilateral triangle. Okay, well, if it's an equilateral triangle, it means all the sides and all the angles are the same. So you might be able to see straight away, well, I can chop this triangle straight down the middle. Okay, but don't stop there, because it says draw the lines of symmetry, so there's more than one. In fact, what helps with these sometimes is to turn it around. If we look at the triangle like that, well, then suddenly we see, oh, actually, we've got another one straight down the middle again. And, well, if we keep turning this round to here, we've got the same thing again. And with lines of symmetry, if we've done them accurately, they should all cross through the same point as well. Okay, so we've got 3 lines of symmetry. You don't have to turn the page, but hopefully that helps to show you that it's got all 3 lines. If it wasn't an equilateral triangle, well, then it wouldn't have 3 lines of symmetry. It might have 1, it might have none. Question 5. Calculate 3/4 of 300. Show your working out and write the answer in the box below. Well, again, we've got a calculator. So 3 over 4 just means 3 divided by 4. Of means times. So we just get 225. Okay. So I'm just going to write 225 here. But what you could do is, if you wanted to show some workings, you could do the step that we saw there. So we can show that this is 3/4 times 300. And we saw that 3/4 was 0.75 times 300. And then we got the answer was 225. Now you don't have to show the workings for something like this. Because it's the calculator section, I'd probably go straight for the answer. But there's no harm in writing this down. And if you do accidentally make a mistake, you might still get one of the marks for showing the right method. Okay, question 6. Calculate 2.002 times 0.9. Okay. Again, this is a calculator question, so we can just type it in. 1.8018. I know it almost seems too straightforward, but we're just doing exactly what they've asked us. If it wasn't a calculator question, it'd be quite different, but it is, so there you go. Don't feel, oh, I can work it out without a calculator and do it. You're not going to get any extra marks for doing that. Okay. Jack and Billy share £210 in the ratio 1:5. How much does Billy get? Right, ratio question. So we're going to draw a ratio table. Jack and Billy, I can just do a J and a B, and I'm going to have a total column. And the ratio is 1 for Jack, 5 for Billy. If that's all they got, then 1 plus 5, the total would be 6. But in fact, the total that they get is 210. So what we want to work out is how are we getting from 6 to 210? And we want to know what we're multiplying it by to get up here, because that's going to be the same for these values as well. So what we say is, well, let's do the opposite of times. We do 210 divided by 6. Which is 35. So what we're saying is we're multiplying that bottom row by 35. Well, 1 times 35 is just going to be 35. And 35 times 5 is going to be £175 for Billy. Okay. Question 8. Show how you could check your answer to question 7. Okay, well, the way we did it was we worked out our multiplier and then we multiplied each. So we did this times 35 and we did this times 35. Well, if we wanted to check it, what we could say is, well, let's make sure that Jack's total and Billy's total makes this total. Okay, so in other words, 35 plus 175, we want to check it makes 210. Well, 35 plus 175, let's see. 175 plus 35, it does make 210. There's our check. There's other checks you could do as well, but for me that seems the easiest, especially as if you've drawn the ratio table. That means you've got everything ready for you. Question 9. You're helping at the Highfield Country Show. The showground needs a fence to be put up around an animal pen. The animal pen is made up of a square with a rectangle added on with gates. So this is our square and that's our little rectangle there. Okay. And we've got a key here telling us that we've got 2 gates here. This is 600 centimetres, that's 45 metres, and we know this is a square. Okay. The gates are 300 centimetres wide. So I'll put that on there, same with that one. And each fence panel is 1.5 metres long. How many fence panels will you need? Show your working out and write the answer in the box below. Okay, so this is a bit of a sort of perimeter question. Okay, so basically we want to know what all of this distance is, not including the gates, and then work out how many fence panels we need for that distance. Now the first thing you should notice is we've got some measurements in metres and some in centimetres. So I know that we've got 100 centimetres in 1 metre. So I'm going to convert. Now, we could convert the metres into centimetres, but we're going to end up with lots of zeros. Because we've got 2 zeros on the end of these, I'm going to say it's going to be easier to divide by 100 to get our measurements in metres. Now, you can use your calculator, but 300 divided by 100, hopefully you'll see that's going to give me 3 metres. So that's going to be the same. And this one, 600 divided by 100. Again, if you think we cancel the zeros, we just got 6 divided by 1, which is 6 metres. Okay, so that's great. We've got this distance. We want to really know how long these sides are as well, okay? Well, if this is 45 metres all the way across, this distance down at the bottom here, this is going to be the full 45 metres, but minus this bit here, yeah, because this is the extra bit. So in other words, it's 45 minus 6, which is 39 metres. And because this is a square, this is going to be the same. Now, this length we need to work out is not going to be the same because we've got this bit of gate that we don't want. So in other words, this is going to be 39, but less the width of the gate, which is 3 metres. So 39 minus 3 is going to be 36 metres. So the total distance round it, well, it's going to be 45 plus 39 plus another 39 plus 36 and then plus 6. Let's say we don't need these measurements because those are the gates. Okay, so 45 plus 39 plus 39 plus 36 plus 6 gives us a total of 165 metres. Okay. Now, we know that each fence panel is 1.5 metres long, so we want to know how many of these panels will make this distance. So in other words, we need to divide that by 1.5. And if we do that, we get 110 panels. Okay. Question 10. A stall has a prize for the person who can correctly guess the weight of a pig to the nearest kilogram. These are the names of the people with their guesses in kilograms. So Jan guessed 208 kilos, Pete guessed 618 kilos, and kilos means the same as kilogram. Kevin guessed 309, and so on. The correct weight of the pig is 20 kilograms more than the mean of all the guesses. Who won the prize? All right, well, we need to work out the mean. So the mean is the total divided by how many, which is another way of saying the frequency. So let's add these all up then. So we've got 208 plus 618 plus 309 plus 863 plus 267 plus 653 plus 455 plus 329 plus 487 plus 732 plus 375 plus 428 plus 165 plus 296 plus 340. Okay, what I would suggest in the exam is that you do that calculation more than once, or maybe you add up one row, then another row, then another, so you can check, because it's very easy to make a mistake there. And the frequency, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 6,525 divided by 15 gives us a mean of 435 kilograms. Okay. They told us the correct weight of the pig is 20 kilograms more than the mean. So we want 435 plus 20, which gives us 455 kilograms. So who was closest to that? Well, in fact, Simon, and I don't think that's me, got the right answer. So Simon wins a prize, whatever that is, whether it's the pig or something else, I don't know. Right, question 11. Another stall has a wheel on a stand. The wheel is divided into 32 equal sectors. So, and we've got them numbered as well. The pointer is spun and has an equal chance of landing on any sector. Each sector is numbered 1 to 32. If the pointer stops on a multiple of 5, you win a prize. What's the probability that you will win a prize with one spin? Give your answer as a fraction in its simplest form. Show your working out and write the answer in the box below. So with probability, unless they say, well, in fact, they've said give it as a fraction, but I'd always start with fractions for probability anyway. We've got 32 possible answers. Now, the ones we're interested in to win a prize are if the pointer stops on a multiple of 5. So we've got 5, 10, 15, which should be there, 20, 25, 30. So 1, 2, 3, 4, 5, 6. So 6 out of 32 possible answers. So this answer is correct, but they've asked us to give it in its simplest form. Okay, well, when simplifying fractions, first thing to do is say, well, they're both even, so we can divide them by 2. Okay, so we can say, well, 6 divided by 2. So we're dividing by 2 here. 6 divided by 2 is 3, and 32 divided by 2 is 16. Can we simplify that any further? Well, I don't think so. The only number that's going to go into 3 is 3, and 16 divided by 3, that doesn't go a round number of times. So we're just going to stop with 3/16. In fact, we can write that in here. Question 12. This is the 6th year that the show has taken place. The table below shows the attendance figures at the show for the last 5 years. So in year 1, there was 3,200. I'm going to put my commas in to make it easier to read. Year 2, 3,700, and so on. In year 6, the attendance is 15% greater than year 5. Show your working out and draw a chart to show the attendance for the 6 years. Right, so we need to draw a chart, but the first thing we need to do is work out our missing value. So we want 15% greater than year 5. Well, to do that, let's work out what 15% of year 5 is. So 15 out of 100 times 4,500. Now that's what it's increased by, so we then need to add on the original 4,500. Which gives us 5,175. Okay, so we've worked out our value. Now we've got to draw our chart. Okay, so because we've got distinct years, we're going to draw a bar chart. Okay, here's our graph paper. And I'm going to go with a vertical bar graph. Yeah, you can do horizontal ones, but for me it's easier to do vertical. I don't know, it's just habit. But up to you. If you want to do a horizontal one, that's absolutely fine. Well, I'm thinking maybe I'll start here so I've got space to write my labels on the graph paper. We've got 6 years, so I'm going to have my years going along the bottom. I could do 1, 2, 3, 4, 5, 6, but it'd be a bit squashed. You really want to use at least half the graph paper. So maybe we could do 2 of these boxes for each year. So we could do 1, 2, 3, 4, 5, 6. Yeah, that feels a bit better. So long as you're using the same width for each of the bars. So these are going to be my years. And that's going to be year 1, year 2, year 3, 4, 5, and 6. And then we had our attendance figures. Well, let's have a look back at those. So the figure we're most interested in is the biggest figure, which is this one. So we want to make sure that when we draw on the graph, we go up to at least 5,175. Now we've got quite a lot of graph paper here, so we've got to think about how much we use. So again, we don't want to just say, I'll make 1,000, 2,000, 3,000, 4,000, 5,000, because it'd be quite small. We've got all this paper up here. So we can think about, well, maybe what about if I use 2 boxes? Because I also don't want to make it too difficult for myself. If I do like 3 boxes or an odd number, it can make it harder to write the scale. But if we had 2 boxes for each 1,000, that would be 1,000, 2,000, 3,000, 4,000, 5,000. And we had 5,175, so we'd want to really go up to at least 6,000. That's okay, that's using over half of the graph paper. So I'm going to go with that. So now I've checked it, I can actually write on 1,000, 2,000, 3,000, 4,000, 5,000. And I say you want to go at least this high. You don't want to stop at 5,000. And this is the attendance. So now we just need to write our values on. So year 1, the attendance was 3,200. Okay, so this is 3,000. Well, we've now got, for 1,000, we've got 10 little boxes here and another 10 here. So we've got 20 boxes altogether. So if you think 1,000 divided by 20 means we've got 50 for each little box. Okay, so if we want 3,200, so this would be 3,000. So if each little box is 50, 2 boxes would be 100. So 1, 2, 3, 4. So we're going to want, so 3,200 is going to be there. Okay, then the next one we had was 3,700. So for year 2, well, I'm going to start with, well, I know halfway is going to be 3,500 here. So again, 2 boxes for each 100. So 3,600, 3,700 is going to be up here. Okay. Then for year 3, we got 4,150. So year 3, 4,000, 4,050, 4,100, 4,150 is going to be here, 3 boxes up. For year 4, we got 1,950. Well, actually, if we go down to 2,000, 1,950, I'm just going to, that's just 50 less than 2,000. So I can just go down 1 box. For year 5, we've got 4,500. This is probably the easiest one. So it's going to be halfway between 4,000 and 5,000. And then for year 6, we've got 5,175 we worked out. So 5,000's up here for year 6. So 5,000, 5,050, 5,100, 5,150. But the next one will be 5,200. We want halfway in between. So it's a bit fiddly, this one. But it's going to be in there. Now you see, I just did the top lines. If you want to draw the bars in as you're going, that's fine. I like to do the tops because if I've made a mistake, it's easier to rub those out and change them. But then when I'm happy with everything, I can then draw in all of my vertical lines to finish off my bars. Okay, and the only thing I haven't got is a title, so what can we call this? Maybe attendance by year, something like that. And let's underline that one. There we go. Okay, Highfield landscaping. So question 13. You are working for Highfield Landscape Gardeners. The owner has asked you to calculate the price of a project for a customer. The customer has a budget of £6,000. The project will need materials costing £990, 2 gardeners and 1 labourer for 12 days of work. And they're telling us that their working days from 9 to 1700. The gardeners are each paid £159.99 per day. The labourer is paid £8.25p per hour. Add 20% to the total for VAT. Can the project be completed within the budget? Show your working and write the answer in the box below. Right, so lots of things to work out. We've got our material cost, that's the easy bit. We want to work out the cost for the gardener and the labourer. Well, how long are they going to be working? 2 gardeners and 1 labourer for 12 days of work. Well, if the gardeners are paid £159 per day, for £159.99, well, we've got 2 gardeners, so times by 2. And they're going to work for 12 days. So times it by 12. Okay, you can split that calculation up if you want, but I'm just going to do it in one go. Times 2. So that's how much per day for the 2 gardeners, and then times 12 days is £3,839.76. That's for the gardeners. Now the labourers are paid per hour. So we want to know, well, how many hours are they working in a day? Well, from 9 to 17. Now, whether you know your 12-hour clock or not, doesn't matter. What we can just do is say, well, 17 minus 9. That's 8 hours. Okay. Now, sometimes you need to check whether they have a lunch break. In this question, they haven't said that. So we're just going to use the 8 hours, assuming that they're working all 8 hours, even though that's probably breaking some sort of labour laws. So they're getting paid £8.25 per hour. So £8.25 for 8 hours for 1 day. And they're also working 12 days. So times 12. But there's only 1 labourer. Okay, so it's just the hourly rate times the number of hours times the number of days. And that gives us £792. Okay. Well, remember we had the original material cost as well. So if we put that up there, basically we want to add all of these together, and then we're going to need to add on some VAT. So let's do it backwards. So 792 plus 3839.76 plus 990. That gives a total of 5,621.76. Let's say, I'll put that in my memory. We want to work out 20% of that because we're going to add it on. Okay, so we want 20% of 5,621.76. Well, we can do 20 divided by 100 times the original amount. Gives us 1,124 point. Well, we're dealing with money, so we're just going to have 2 decimal places. So 35, 2's less than 5, so just £35. So we then want to add these 2 together. So 1,124.35. I've still got the memory recall, so add them together, gives us 6,746 and again we want 2 decimal places. 2 is less than 5, so it's going to be £6,746 and 11p. Okay, can the project be completed within the budget? Well, the budget was £6,000 and this is more than £6,000, so no, it can't be completed within budget. Okay. Question 14. A customer wants their garden planted with grass seed. They give you this plan of the garden. Okay. So we've got 12 metres, 9 metres, 8 metres, 6 metres, a couple of lengths they haven't given us. And we're told that grass seed, you need 35 grams for every metre squared, and a box is 1 kilo. How many boxes of grass seed will you need to buy? Right, so we want to work out, this is an area question. We need to work out our area, work out how much grass seed we need, and then how many boxes do we need to make up that figure. So we can, basically we want to split this up into rectangles. We can either split it this way or this way. It doesn't really matter. I'm going to split it down here. So if we remember the area of a rectangle is the length times the width. So on this rectangle here we got 9 metres. 9 times the width, which is 8. 9 times 8. That gives us 72 metres squared. Right, now we want the area of this rectangle as well. Well, the length is 6 metres. The width, well, we haven't got this width. We do know the total width is 12, and that this distance is 8. So 8 here, so this is also going to be 8. So this distance must be the full 12 minus the 8. So 12 minus 8 gives us 4 metres. So 6 times 4 gives us 24 metres squared. Okay, because it's area, it's always going to be squared. So, our total area is going to be 72 metres squared plus 24 metres squared, which gives us 96 metres squared. Okay, right, so how much seed do we need? Well, we need 35 grams for every metre squared. So we want, let's do it over here. So we want 35 times 96. Okay, or 96 times 35. That's going to be 3,360, and that's in grams. Okay, well I know that 1 kilogram is 1,000 grams. So we want to divide this by 1,000. And if we do that, we get 3.36, and that's 3.36 boxes that we need. Well, if you try and go in a shop and say, I want 3.36 boxes, they're going to say, I can't sell you 0.36 of a box. You're going to have to buy 4 boxes. And finally, we've got question 15. A playground needs wood chips to be laid under the swings for safety. The area of the swings measures 13 metres long and 5 metres wide. The wood chips need to be 10 centimetres deep. The wood chips are delivered in the following bags, which hold 1 metre cubed of wood chips and costs £99. Only full bags can be bought. What is the total cost of the wood chips needed? And it just says down here, show your working out and write the answer in the box below. Okay, right, well it's quite hard to really see what's going on here. So let's draw a little picture. So we've got this space which is 13 metres long and 5 metres wide. Okay, and the reason I've drawn it at an angle here, well, one, it's just a sketch, but it's 10 centimetres deep, so I can also draw on here. We're going to make this sort of 3D. So this is the kind of area that we're trying to fill. So we're saying that this is 10 centimetres deep. Okay. Now, we're working in metres cubed. So we've got metres here, metres here. At the moment, this is in centimetres. Now, we know there's 100 centimetres in 1 metre. So if we want to turn this into metres, we're going to need to divide it by 100. Okay, so we've got 10 divided by 100 gives us 0.1 of a metre. So now all we need to do is work out the volume of this, and it's going to tell us how many metres cubed of wood chips we need. Okay, so we can say, well, the volume of a cuboid, which is what this is the length times the width times the height. So the length is 13, the width is 5, the height is 0.1, because it has to be in the same units as all the others. So 13 times 5 times 0.1 gives us 6.5 metres cubed. Okay, now similarly to before, in question 14, well, we saw that you can't buy part of a, I can't remember what it was, part of a box of grass seed. Similarly, we can't buy part of a bag. Yeah, only full bags can be bought. Well, if we need 6.5 metres cubed, well, we're going to need 7 bags. Because 6 won't be enough, so we've got to have 7, even though we end up with more than we need. So we've got 7 bags. They cost £99 each. So 7 times 99 gives us £693, which we can write down here at the end. And that's the end of that paper. So I hope you liked it. Please subscribe to the channel, like the video, add any comments you've got, and I look forward to seeing you all again soon. Thank you.